We're going to work with a special triangle, a 45, 45, 90 degree triangle. In a 45, 45, 90 degree triangle, we have two congruent sides because they are opposite two congruent angles. So we have an isosceles right triangle. The formula for finding the missing sides of an isosceles right triangle or a 45-45 degree triangle is we're going to name the legs, the congruent legs, x and x, and then we're going to take that value, multiply it times the square root of 2 to find our hypotenuse. So on this first triangle, you'll notice that we have the two congruent sides marked because we know it's a 45, 45, 90 degree triangle. If one leg is 80, then the other leg, x, is going to be 8. If one leg is 8, the other leg is going to be 8. And then for y, we're going to simply take x times the square root of 2. On this triangle, you notice that we have two congruent legs. One's 25, so y would also have to be 25. And then the hypotenuse is the length of one leg times the square root of 2. So it's going to be 25 square roots of 2. Now here we've been given the hypotenuse and we have to find the two legs. So we know that the hypotenuse is going to equal x times the square root of 2. So we're going to take x square roots of 2 is equal to 19. Divide by the square root of 2 because it's multiplying x here. Divide by the square root of 2. And then I have x is equal to 19 divided by the square root of 2. Now, we're going to need to rationalize because we're not allowed to have a radical in the denominator. So when we rationalize, we're going to multiply the numerator and the denominator by the square root of 2. That's going to give us 19 square roots of 2. Let me move my x and y here. And that will be over the square root of 4. Now we're going to simplify 19 square roots of 2, and the square root of 4 is going to be 2. So the lengths of our two legs, x and y, are going to be 19 square roots of 2 over 2 and 19 square roots of 2 over 2. We're going to do a quick check here. So if we take 19 square roots of 2 over 2, which is one leg, and multiply it by the square root of 2 over 1, which is what our formula is, that would give us 19 times the square root of 4 over 2, which would give us 19 times 2 over 2, which gives us 38 over 2, which gives us 19, which is indeed the length of the hypotenuse that we were given. All right, let's look at number 4. Number 4, we have a hypotenuse of 160. Again, we know that 160 is going to equal x times the square root of 2. And so we're going to do x square roots of 2 is equal to 160. We're going to divide by the square root of 2. And we're going to have x is equal to 160 divided by the square root of 2. Now we're going to rationalize the fraction, rationalize the denominator by multiplying by the square root of 2 over the square root of 2. And we're going to have x is equal to 160 square roots of 2 over the square root of 4. This is going to give us 160 square roots of 2 over 2. You'll notice every time we rationalize a denominator, we simply get the denominator without the square root sign. So this is going to be the length of our sides, 160 square roots of 2 divided by 2, which is, we haven't simplified that yet. So let's go back and simplify. 160, because we can divide like parts, 160 divided by 2 is going to give us 80 square roots of 2 for the lengths of our two sides, and 80 square roots of 2. Now, we can check because we can do 80 square roots of 2 times the square root of 2 would equal 80 times the square root of 4, which would equal 80 times 2, which equals 160. So we now know that we do indeed have the correct lengths of the two legs. And that's how you work with a 45-45 degree triangle.